It is a humbling but very motivating fact that a person currently has to die before doctors can make a diagnosis of chronic traumatic encephalopathy, the degenerative brain disease that afflicts many professional football players and other athletes who have sustained repeated blows to the head. After all, if it were possible to diagnose CTE in the living, those athletes and the physicians who care for them could probably do something useful with that knowledge. On Tuesday, the Boston-based researchers who have pioneered the identification of CTE in contact sport athletes said they may have found a way to recognize the degenerative brain disease in people while they're still alive. Researchers from Boston University's School of Medicine have identified an inflammatory protein circulating in spinal fluid that may reflect the presence of CTE in patients' brains. That telltale protein, called CLL11, appears likely to make its way into the bloodstream, where it might readily reveal the presence of a degenerative process akin to premature aging in the brain. "This is just the beginning," said Dr. Anne McKee, co-author of a study published Tuesday in the journal PLOS ONE. "We need to find it at the earliest stages." McKee directs Boston University Medical School's Chronic Traumatic Encephalopathy Center, which recently revealed it found evidence of the degenerative disorder in 110 of 111 professional football players who donated their brains to the program upon their death. In life, all of those donors had suffered behavioral symptoms ranging from depression and impulsiveness to substance abuse and aggression. The loved ones of most of these players generally reported cognitive and behavioral changes that worsened over time. An important aim of McKee's group is to devise a blood test that could alert a young athlete to avoid further collisions, or warn a retired athlete to take steps that could slow a gathering degenerative process, McKee said. But researchers will need to surmount many more hurdles before that's possible, she added. Among other objectives, researchers will need to demonstrate that the protein they've zeroed in on is a reliable sign of CTE, and that it can distinguish CTE from other degenerative brain diseases. And they must understand more precisely how levels of CLL11 that can be measured in the bloodstream reflect those present in the brain. In this early effort to test whether CLL11 could help physicians diagnose CTE, researchers tapped into several brain banks. They set out to compare the preserved brains of 23 former athletes who had been diagnosed with CTE, 50 deceased patients diagnosed with Alzheimer's disease, and 18 people who had been cognitively healthy when they died. The researchers focused on levels of CLL11 in the dorsolateral prefrontal cortex, the critical brain structure that is first and most markedly affected by CTE. There, they measured CLL11 levels and found them markedly higher in the brains of those with CTE than in those who had Alzheimer's disease. Even starker were the differences in CLL11 levels between brains beset with CTE and the brains of people who were cognitively healthy at death. The new study also found that CLL11 levels in the prefrontal brain regions of football players rose as a function of more years spent on the gridiron. In the brains of former pro football players who played longest, levels of the protein were generally higher than levels in the brains of players with fewer years on the field. From a subset of the post-mortem samples they tested, the researchers discerned that the spinal fluid of donors also contained CLL11 in levels that corresponded roughly to those seen in the brain. The researchers didn't draw blood from living patients, but it is generally understood that anything that has escaped the brain into cerebrospinal fluid will find its way into circulating blood as well. McKee said that her colleagues' suspicions fell upon CLL11 as a possible biomarker for CTE because it is a common sign of inflammation in the brain's tiniest blood vessels. As McKee and her colleagues deepen their understanding of CTE, she said, it's looking more and more likely that the tiny vessels that carry oxygen to the brain's farthest recesses become leaky and compromised. So looking for the downstream effects of such leakiness seemed like a promising tell for CTE, she said. Finding a biological marker for CTE may also be a key step in identifying ways to prevent, slow or even reverse the mental slide that continues long after a player has retired and the blows to the brain have ceased, McKee said. Melissa.Healy@latimes.com @Melissa Healy. More in Sciencey. New York, major crime complaints fell when cops took a break from proactive policing. Mosquitoes spread deadly diseases, and public health experts hope to fight back with this new emoji. Plant-eating dinosaurs may have dined on crustaceans on special occasions, study says. Medical research. Scientific research